Okay, so I will click on apply and deviation. Okay, yep, so it's a correct deviation already, 27. The inclination, yeah, you can input, of course, your trajectory, measured depth versus true vertical depth. In this case, I already prepared that, and yes. So this is the trajectory of my well. And then the equipment, okay, for the tubing, I will call it tubing. Okay, so I will locate the end of the tubing at 3,250 feet, and the external diameter is 2.875. It's 278 inches of tubing with an internal diameter of 2.441. So it's a typical tubing to be used in this configuration, in this well configuration. Okay, and absolute roughness, typical value 0.0012. Flow configuration, of course, through tubing, no drift diameter. And then casing, so I will call my casing as casing. So the end of measured depth for my casing is at 3,400 with the final diameter, okay, it's 7 inches, and the internal diameter is 6.1. Internal diameter of casing is important because, of course, don't forget we will use electrical submersible pump in this case. Okay, so far so good, no restriction. But if you have like valve, you can input that or some restrictions, but I will delete that. Trace points if you have, and temperature model. Okay, I will just use calculated surface surrounding temperature. The surface temperature 86 degrees Fahrenheit. If you're wondering what is the centigrade value, you can also check the Celsius value. It's 30 degrees Celsius. And yep, it will be calculated. So this is the, at this depth, measured depth, it will be calculated. So it's just like that. It's very easy. And ESP data. Okay, so currently in this model file, I have DN 3100 radar pump, okay, with number of stages 160, pump wear factor 1, okay. But yeah, this is the range of the performance, okay, around 2000, the minimum flow rate up to 3900, okay. So this is the motor model, okay, 375 nameplate rating, operating rating for the motor, and pump environment, okay. This is the location of the pump location, and maximum OD, maximum minimum equipment OD, operating frequency 60 hertz, upstream temperature 90, pump name radar 3100, and so on and so forth. But I actually want to use another pump. So let me delete this first and click on this one. Okay, and select catalog data, expand the radar, expand this window. I already input my this pump, DN 2400, okay, with OD of 4 inches and shaft limit at 60 hertz and housing limit. I already input all the data for this specific pump on the WellFlo, so I can just use that. So I will use DN 2400 REDA in this case, and the minimum flow rate is 1500, maximum flow rate 3200. So if you want to operate this well, make sure you don't operate below 1500 or greater than 3200 because it will lead to down thrust or up thrust. Okay, so far so good. And let me check my another sorry, another data for ESP design to know how much or how many stages I will have in this specific case. Okay, so I'm going to use 60 stages. Okay, and then motor model. Okay, for the time being, I only have motor of this one. Okay, 90 horsepower. Okay, and then motor model. Okay, Reda. Yeah, I will use this one, 375 SX series. Okay, and I think that's all. Later, I'm going to also dig in more deeply in another calculation for the ESP design so we can move forward, apply, and go to analysis.